Okay, so in our last video, we looked at how to do this problem in example 2, solving a trig equation by using identities and finding a least common denominator. So to practice that strategy, if you did not yet take a second to solve this problem, 2 sine of x minus cosecant of x equals 0 on your own, go ahead and pause the video, and then once you've tried it, come back and go through the answer with us together. So when we take a look at this problem, 2 sine of x minus cosecant of x equals 0, we're reminded that cosecant is the reciprocal of sine. On the trig identity hexagon, remember the reciprocals are diagonal from each other. So the reciprocal of cosine is secant, the reciprocal of tangent is cotangent, the reciprocal of sine is cosecant. And so I can replace that cosecant then using that reciprocal identity to get 2 sine of x minus 1 divided by the sine of x equals 0. Right? And that was applying the reciprocal identity. So now I have a fraction that I want to subtract. That means I would need a common denominator. So to get a common denominator to match this fraction with a denominator of sine of x, I'm going to multiply this fraction by sine of x divided by sine of x. And that will simplify to 2 sine squared x in the numerator over sine x in the denominator minus 1 divided by sine x, and that's equal to 0. Okay, now that I have a common denominator, I can subtract these numerators. So my next step, I'll have 2 sine squared x minus 1 all divided by that LCD sine of x, and that's equal to 0. Okay, now going to go ahead and cross multiply in order to solve that proportion, and the numerator here times 1 is just going to be the same thing, 2 sine squared x minus 1 equals, and then 0 times anything is 0 on the other diagonal. And now I'm going to go ahead and try to solve this for x. So I'm going to start by adding 1 to both sides, and then 2 sine squared x is equal to 1. Then I'm going to divide both sides by 2, and sine squared x is equal to 1/2. And here we want to be really careful, because a lot of students at this point are tempted to notice that 1/2, notice the sign, and think, oh, sine is the y coordinate on the unit circle, so that must mean pi over 6 is an answer. It's not, because this is sine squared of x equals 1/2. We haven't gotten the x by itself yet. So to undo a square, we need the inverse operation, which is a square root. So we're going to square root both sides, and then we'll have sine of x is equal to, and remember, whenever you square root a squared function, you have two answers, a positive and a negative. So we have a plus or minus square root of 1/2, which is the square root of the numerator. Square root of 1 is 1. And the square root of the denominator is the square root of 2. So sine of x is equal to plus or minus, and then we're going to rationalize that denominator, and we have a plus or minus square root of 2 over 2. So to get the x by itself, now we're going to do an inverse, and the inverse of sine is arcsine. So x is equal to the arcsine of plus or minus root 2 over 2. Okay, so our next process in figuring out where that happens on the unit circle is to look in the first quadrant first, and then use reference angles to find all the rest of the answers from 0 to 2 pi. So the sine is the y coordinate, so we want to find an angle in the first quadrant that has either a positive or a negative y value of root 2 over 2. So looking at our angles here on the unit circles, first quadrant, we see that at pi over 4, there is a y coordinate of positive root 2 over 2. So our first solution is going to be pi over 4. Okay, now we're going to look in the other quadrants. And we don't really need that acronym, the All Students Take Calculus this time, because we're looking for where it's a positive and where it's going to be negative sign with a root 2 over 2. So that's going to mean we get 4 answers, one from each quadrant. We already found the quadrant 1 angle, which was pi over 4. So to get that angle reflected into quadrant 2, using that quadrant 1 reference angle, right, this half the circle is 4 pi over 4, and the whole way around the circle would be 8 pi over 4, because there's 2 pi radians in the circle. So to get from here to here, that was going up pi over 4. To go backwards, then we would need to subtract pi over 4. So 4 pi over 4 minus pi over 4 gives us an answer here at 3 pi over 4. So x equals 3 pi over 4 would be the second solution. Now to go into quadrant 3, where sign is negative, because sign was positive in quadrants 1 and 2. Now in quadrant 3, we're going to start at that x-axis, that 4 pi over 4, but this time we're going to add, because we're going counterclockwise. So we're going to add pi over 4 to get a solution at 5 pi over 4. So x equals 5 pi over 4 is another answer. And then our last solution will come from quadrant 4, where where sign is also negative, and that would be coming backwards from 8 pi over 4 in the clockwise direction. So we would subtract pi over 4 from 8 pi over 4 to get a solution at 7 pi over 4. And so x equals 7 pi over 4 would be our fourth solution. So now in the graphing calculator, to check those answers, okay, we're going to go ahead and make sure that we're in radian mode, which we are, and see if I can slide this over a little bit so we can see everything at the same time. Maybe I can lift this up and get a little bit more in the view. There we go. Okay, so now first we're going to store pi over 4 as the x, and then type in our original equation, 2 sine x minus, and there's no button on the calculator for cosecant, so we're going to need to use that reciprocal identity and enter that as 1 divided by the sine of x to get the cosecant of x. Then second and, or no, not second, second, and then math gets us the test menu, and number 1 here in the test menu is the equal sign. And we want to see if that is equal to 0 from the original equation. And recall from the other videos that when we type in that equals, we're asking the calculator to check this solution with a yes or no answer. So when we press enter, if it says 1, that means yes, it checks. If the calculator returns a 0, that means no, it doesn't check. So we press enter and we get a 1, and so we know that pi over 4 checks as a solution. Next, we're going to check the 3 pi over 4 by storing that as x, and then we're going to arrow up to where we typed in the equation and press enter to copy it down. Then we'll press enter, and again we get a 1, which means that 3 pi over 4 also checks. Okay, now we'll check 5 pi over 4 by storing that as x in the calculator, and we're going to arrow up to that equation again, press enter, and we get back a 1. So 5 pi over 4 also checks. And then last but not least, 7 pi over 4, store x. And we're going to arrow up to that equation, press enter, and we get a 1, and so 7 pi over 4 also checks as a solution. Okay, so I hope that helps give you some extra practice with solving trig equations using identities and a least common denominator.